Today's video is going to be focusing on success criteria pertaining to developing and evaluating a controlled experiment. When you create a controlled experiment, you have to know what the variables are. And variables are factors that might influence the results of an experiment. And what makes an experiment controlled is when only one thing is changed and tested at a time. Because if we change more than one variable at a time, then there's no way to determine what actually will be making a difference, and thus your experiment is invalid. In order to really understand how variables are related to each other, we need to figure out a sample experiment. So let's pretend in our mind's eye that we're curious about what will clean a penny better, vinegar or water. So we don't forget, let's record what our sample experiment could be at the top. So we can say cleaning a penny, water, or vinegar. Whenever you start thinking about an experiment, typically the first thing that comes to mind is a question. And in IB, we're going to be calling this a research question. And a research question is one that's answerable, and we use it to introduce our experiment. In English, you might call this a hook, and it's a way to get your reader's attention. So in our pretend experiment, our research question could be the likes of what will clean a penny best, water or vinegar. And after you determine your research question, you might actually have to do some research about perhaps the property of water and vinegar, what kind of grime could be on a penny, what oxidation might be, and the properties of all of those things combined in different combinations. The reason the research question has to be answerable is that your proposed answer is your hypothesis. And a hypothesis is an educated guess. And that educated guess is used to lead your investigation and gives you an answer to the research question. So the point of collecting data is to determine if the hypothesis can be backed by evidence. And we don't use the word prove, we use support your hypothesis or negates your hypothesis. Because nothing is absolute. So your hypothesis is essentially your educated guess or your opinion based on the research that you've collected. And a hypothesis is typically an if-then statement. So an example hypothesis in this particular experiment would be if a penny is cleaned with vinegar, then the penny will be shinier than before. Now it's time to actually identify our variables. Our first variable is our independent variable, and it's the variable that I, key letter there, change. So this is the one variable that is being changed and tested in the experiment, which in this case is cleaning a penny with different solutions. And a solution is a type of liquid, which we'll learn more about in our matter unit. So if the independent variable is the variable that I am changing, my dependent variable is actually my data collected. And both dependent and data start with D, just like independent and I both start with the letter I. So a dependent variable is data or observations collected during the experiment to see how it responds to what is being changed and tested. Now here's the thing. There are two different types of data we can collect. When you think of data, typically that means quantitative. Quantitative data deals with numbers. Observations is also known as qualitative data. And you will need to know the difference between both of those. But coming back to our pretend experiment, if we're trying to decide which cleans a penny better, our dependent variable is going to be a qualitative observation because it's how clean a penny is post or after cleaning. Now, if we're only allowed to change one thing about our experiment to see if it makes a difference, that means that the rest of our variables are going to be constant variables. And when you think about the English language, constant means the same. But in IB, these are called control variables. It means the same thing, but IB looks at it as if we are controlling the other variables, while in normal traditional schools, we're keeping things the same. They're going to mean the same thing when they both have the word variable, but just be aware of the different terminology. So a constant variable, or in IB, a control variable, are variables that are kept the same throughout the experiment to ensure that only one thing is changed and tested at a time. So this is where you as a scientist are going to have to start brainstorming. So you would want to keep maybe the amount of solution the same. You would want to keep the amount of time the penny is in the solution the same. You would want to keep the year of the penny the same. And I know that seems really abstract, but different years of pennies have different physical properties because they're made up of different types of metal. And you want to keep your procedure or your method the same. Now, what students normally get confused by is the difference between control variables and a control experiment. And the key word here, guys, is a control experiment that is typically a normal setup or result. So essentially, this is a scenario where the independent variable, the IV, independent variable, is removed. And that's really important to remember. And we use it as a comparison. Like, did our experiment actually make a difference, or do we just waste our time? So a control experiment in this particular case would be a penny that hasn't been cleaned at all. And the reason being, so we can compare our clean pennies to the penny that has not been cleaned to see if cleaning them made a difference. And last but not least, we have our conclusion. And an IB will also have an evaluation in which you analyze your data and you summarize your results. And you'll refer back to your research and purpose question, and you're going to identify the relationships found in the experiment. So if we were to write a conclusion sentence for this, let's pretend that vinegar did in fact clean the penny better than water did. So we can say, after the experiment, we determined that vinegar cleaned the penny better. which supports, keyword here is supports, not proves, our hypothesis. Now, after defining all the different variables and giving an example of each, something else that we're going to have to keep in mind is that we're going to be graphing our variables to give some of our more visual learners and visual readers something to look at. Essentially, we're going to be modeling our data. So your dependent variable, what you're measuring or monitoring, if it's numerical. So remember that only qualitative data goes into an XY scatter plot, which is what's below, and we'll learn more about graphing in a little bit. That's going to be going on our y-axis. So remember, when you have a graph, your y is here, going vertically, and your x is on the horizontal axis. Then your independent variable, what you were changing to see if it made a difference, goes on your x-axis. So we can compare the two numbers that we obtain, and we can make an XY scatter plot so that we can see if there is a relationship. So in this particular graph, I see that I have distance in miles over time. And I'm looking at a distance and time graph of two moving cars. The title is really important because it tells me, even though I didn't do this experiment, what's going on. So after looking at this experiment, I can see that this line, this black line right here that I'm now highlighting blue, that looks like a linear relationship. Car 1 moved at a consistent rate. While car 2, the red line, which I'm now highlighting in green, has an exponential relationship because it starts off slow and then gets relatively faster. If you're confused a little bit on how to read this graph, don't worry, there will be another video for later this week. But what's important to take away from this particular segment is that graphing data is a really beautiful way to express our variables and to support or even negate our original hypothesis and use that stuff in our conclusions. Now let's practice identifying these variables. Over to the side, I have some helpful hints. And this is the order that I would recommend answering these questions in. My first hint is to ask yourself, what are we measuring? What data are we collecting? Because this is our dependent variable. So in our first experiment, it says the height of bean plants are recorded daily for 2 weeks when a fertilizer is used. So when we see the word measuring, we have to remember words that mean the same thing but might be different. So for example, record, monitor, or collected are all words that mean measured. So in my first experiment, I see that the word recorded is there, and that's in reference to the height of the bean plants. So the height of the bean plants must be my dependent variable. The next question I'm going to be asking myself is, why am I measuring this? What am I doing in this pretend experiment that I would care about the height of the bean plants? So after rereading my experiment, I see that the height of the bean plants are recorded daily for 2 weeks when a fertilizer is used. So it appears that I'm adding a fertilizer. So that would be my independent variable. Now I have to think about things that I'm keeping the same. And that's not necessarily in my experiment, but it might be. So I see that I record daily, but I also record for 2 weeks. So those are the two really obvious ones. So daily recording and the duration or the amount of time I spent doing this experiment. Another thing I might want to keep in mind to keep the same, this is where I have to think outside the box, is I might want to keep the amount of water the same. Because I just want to make sure just the fertilizer is affecting its growth. I also might want to keep the environment the same. Like, is it getting the same amount of sunlight? Is it getting the same amount of rain, which would equivalent to the amount of water? Is it in a greenhouse? Is the temperature constant? What's going on? Typically in these activities, I'll only ask you to identify 2 or 3 constant variables because there could be an infinite number of them. So when you see the word control in these activities, I need you to think about the control experiment. So what can we compare our results to? So our control experiment is the removal of the independent variable. So if my independent variable is the addition of fertilizer, my control variable is going to be no fertilizer used, so we can compare to see if our fertilizer made a difference or not. Let's do another example together. Remember, my first question is, what are we measuring? What data are we collecting? And my pretend experiment is hamsters are kept at different temperatures for 6 weeks and body fat percentage is recorded. Well, remembering our like words, record, monitor, and collected are all terms for measuring. And I see the word recorded, and I see that there's body fat percentage. So if body fat percentage is recorded, that means that that's my dependent variable because that is the data I'm collecting. The next question you ask yourself is, why are you measuring this? Why do we want to measure the body fat percentage of hamsters? What's going to make a difference in that? And after rereading the experiment, it looks like there's different temperatures. So one can imply, or one can kind of assume, that there might be really, really cold temperatures and really, really hot temperatures. The next question we ask ourselves is, what are we keeping the same? So I see that there are hamsters, and I see that there's a time duration. So I'm going to say the duration of the experiment, which is 6 weeks. We might want to have the same breed of hamster. We're going to want to keep their food and water supplies the same because we just want to see if temperature makes a difference. And although hamsters are pretty hard to control, we might want to have similar, or not even similar, the same exercise equipment in their cages, like those hamster wheels. Not like a little treadmill, that's silly. And the very last thing we ask ourselves is, what can we compare our results to? What would be our control? And that one we're going to think pretty hard about. But remember, it's the removal of the independent variable. So if our experiment is focusing on different temperatures, that means our control variable would be keeping hamsters at a common temperature, which in this case would be room temperature. What you're going to do on your own is you can re-watch this video as many times as you want, but you're highly encouraged to use the questions up here and complete question 3 on your own, and we'll be going over it in our next class.